integration is reverse process of differentiation. That means it is also considered to be anti-derivative. That means when we integrate some function, then we consider that the function is derivative of another function. That means if I have derivative of a function fx as phi x, let's say phi is a notation, then we will consider that integration of phi x, I will denote it by a sign, this one, with respect to x, that means dx. That means this function, if we integrate, it will give the original function. That will mean we will get function of x. So when we differentiate fx and get a function phi x, then integrate of this integration of this phi x will give the original function. But there is a problem, there is a concept, and that is called indefinite, because if you add one constant here, derivative of fx plus a constant, then the idea will be same. That means it will be phi x. So when we integrate, this idea will be plus c. So there is a concept that after integration we must add a constant c at the end of the integration. This c is called integration constant or an indefinite constant. So this idea of integration, what we are now discussing, is an indefinite integration. Today we will discuss the basic ideas and formulas of integration, which are all algebraic type. Now the basic formulas we find that first one will be x to the power n dx. That means any function x to the power n, power is n, dx, the result will be x to the power n plus 1 by n plus 1, then plus c, that constant. But there is a problem that n should not be minus 1, because if it is minus 1, then the denominator will become 0 and we cannot get any definite answer, that is a defined answer. So we must be careful about the power of n. X should be a minus 1, not minus 1. It should not be a minus 1 value. Now if it is x to the power minus 1, that means if we get the situation that x is equal to power of x is minus 1, then the formula will not be same, and the formula will be log x, which is of course a mod sign, because log is always a non-negative value, log of a non-negative value, and base of log is automatically in calculus we take e. If this e is understandable, we can understand this e, which is a natural base. Now these two formulas we are having, the basic formulas of algebraic integration. We can have some more, like 1 dx. Then what we find that 1 dx will be x plus c. If we trace back to differentiation, we know derivative of x is 1 and constant is 0. So 1 dx, integration 1 with respect to x, that is 1 dx will be x and constant. The next formula what we can have is e to the power kx. That means the power of e is exponential, is k. Then integration of this e to the power kx will be e to the power kx divided by k. In derivative we have seen differentiation that it will be k to the power kx, but it will be here e to the power kx by k. K is any number, constant. And on this idea we have one more, that is a to the power kx. A is any other number than e, and the result will be a to the power kx, similar to e to the power kx, but it will be divided by k as it is before, and there is a log a base e. So these some few formulas are basic formulas of integration. And now what we will do, so we'll see some examples. The examples are to simplify the function first, then to separate the terms and integrate. That means we can take an example. First example we can take that integration 2x cube minus 4x plus 5 by x. So here what we are finding that the expression, the function is 2x cube minus 4x plus 5 by x. What we will do, we will first separate. That means we don't need to simplify too much. Only thing we are having x is in the denominator. So what we will write, 2x cube first term dx, that is separated, then minus 4x dx, the second term, and the third term is 5 by x. We can write 5x to the power minus 1 dx, because it can be simplified to the power as minus 1. Now we will proceed this way, that 2x cube we can write 2 into x cube integration. The reason behind it is that 2 is a coefficient of x cube. Now 4 coefficient will be taken before, then 4x to the power 1 dx, because x means x to the power 1, and 5x to the power minus 1 dx. So if we look back to the formula just now discussed, it will be 2x to the power 3 plus 1 by 3 plus 1. What is the formula? The formula was x to the power n plus 1 by n plus 1 minus 4x to the power 1 plus 1 by 1 plus 1, and then 5. We cannot write like this, because x to the power minus 1 cannot be the same manner. It cannot be same manner. It will be log x. And finally the constant of integration c. So c should be added at the end. So our answer is will be x4 by 4 minus 4x square by 2 plus 5 log x plus c. So our answer is x4 by 2 minus 2x square plus 5 log x, that is the mod x, and constant. This is the answer to the question. So similarly we can take another example. This example is a simple problem of power of x to the power n, or like that. We can have some other example like square root of 2x minus this one. So here also we are having the question of how to simplify. We can simplify it. So we need to simplify these terms. We need to simplify and then proceed. And when we will simplify, we will write root 2 into root x, because root 2x is root 2 into root x dx. We are simplifying. Then the second term will be 1 by root 2 into 1 by root 2 is multiplied with root x. Now this root 2 is a constant. It will be taken outside. Root 2 outside, root x means x to the power half dx. And this root 2 in the denominator, it will be also a constant. It will be outside. And that term in the denominator we can write in the numerator. That means we can take x to the power minus half dx. So now we have our application of formula ready, because we can apply the formula x to the power n in both cases. X to the power n in both cases, it will be root 2 x to the power half plus 1 by half plus 1 minus 1 by root 2 x to the power minus half plus 1 by minus half plus 1 plus c. So what you are finding in this result, that root 2 into x to the power 3 by 2 by 3 by 2 minus 1 by root 2 x to the power half by half plus c. When we add c after completing the integration, that means the formula, whenever I put this step, we have replaced the formula, we have used the formula, and we have added c there. And the result finally 2 root 2 by 3 x to the power 3 by 2 minus this 2 will be numerator, that is 2 by root 2, then x to the power half plus c. We can simplify a little bit, that is 2 and root 2 we can cancel, or we can leave the answer here, because integration we have done. We can write one more step, that is 2 root 2 by 3 square root of x cube. This way we can write. If you leave the answer here, it is also correct, but we can write one more, because 2 by root 2 we can write, cancelling the root 2 in the denominator, we will get only root 2 and x to the power half. So this type of answer we are finding in this case. Therefore, this is a type of problem in integration of algebra. Now one more problem like this, the simplification type, like x to the power 4 plus x square plus 1 divided by x square minus x plus 1 dx. So how to solve this question, this type of questions? This type of questions we need to solve by simplification, because in denominator we must simplify the denominator. How we will simplify the denominator and numerator? Not simplify the denominator, we have to simplify the numerator and denominator such a way that we will not get the denominator there as much as possible, because we are now today discussing the basic ideas. So in this basic ideas, what you are finding, x square whole square plus 2x square, that means a square plus 2ab plus b square, that is 1 square, but it's not 2x square, so we subtract x square. So this thought, why? Because from this first three terms we will get a whole square, and x square extra term we have subtracted, so our idea is x square minus x plus 1. Now what we find, x square plus 1 whole square, a square plus 2ab plus b square minus x square. So we are getting a clear algebra a square minus b square formula. This first three terms gives us a square plus 2ab plus b square, that is a plus b whole square, minus this one. Now what we find in the numerator, clear algebra, a square minus b square formula. And a square minus b square formula tells us a plus b into a minus b. That means a, this is the a part, plus b into a minus b, and whole expression divided by this one. So when we are observing this, we are getting these two cancelled. So now we are left with this expression, and that expression is x square plus 1 plus x dx. We will separate x square integration dx, then plus 1 dx, and the last one is plus x dx. So we have just seen that x square will be x to the power 3 by 3, because 2 plus 1 by 2 plus 1, plus x, 1 dx is x, and plus x is x square by 2, because 1 plus 1 by 1 plus 1 plus c. So this is the answer to this question. We can have one more example of another topic, another type, not topic, we can have another example, another type like this. E to the power 3x plus e to the power x. This one. Now how to solve? If you watch this expression, we can have an algebraic concept that e to the power 2x plus x. E to the power 3x means e to the power 2x plus x. And if you watch e to the power x, that will be e to the power 2x minus x. Why? Why I am writing this? Because in the denominator I am finding that we are having e to the power x plus e to the power minus x. So if you watch the last denominator part, not the last denominator part, we are finding e to the power 2x plus e to the power minus x. Now in the denominator we are having this expression, in the numerator we can take e to the power 2x common, because in both the expression we have e to the power 2x. So if I take e to the power 2x common, we are left with, we are having this expression left. It will be cancelled, and hence our final expression of this integration becomes e to the power 2x only. So since it is only e to the power 2x, we can finally answer e to the power kx rule, that is e to the power 2x by 2 plus c. So this is another example of how to solve. So basically integration means solving. Before that we will simplify. Now we can have one more example like 6 to the power x plus 3 to the power x by 3 to the power x. How to solve? So 9 to the power x. 9 to the power x by 3 to the power x. How to solve? We can separate 6 to the power x by 3 to the power x dx. Then 9 to the power x by 3 to the power x dx. So what you are having, 6 to the power x is 2 into 3. That means we can write 2 to the power x into 3 to the power x, because 6 means 2 into 3 and denominator is 2 to the power x, plus 9 to the power x is 3 to the power x into 3 to the power x. So it will be 3 to the power x into 3 to the power x, that is 3 to the power x whole square divided by 3 to the power x. So 3 to the power x cancelled in both cases. That means we can have this way, we can do this way, and 3 to the power x common from the numerator and then cancel out. Yes, instead of that I have simplified individually. It can be done by simply taking 3 to the power x common from numerator and then proceed. Ultimately what you are having now is 2 to the power x dx plus 3 to the power x dx. So we are having the formula a to the power x by log a plus a to the power x by log a plus c. So this is the final answer of integration. So algebraically we will integrate, indefinite integration we call like this.